Welcome to this Cimatron webinar. Our topic today is cooling design. We're going to look at two different methods for creating water in Cimatron. First, the sketcher method, and second, the add cooling item with channel method. Next, we're going to look at some analysis tools that can help you with determining if your cooling design is efficient for the part. And last, we're going to check the cooling circuits to make sure that they are complete before sending them down to the shop floor. My name is Michael Terrio. I am in tech support at Cimatron. Please put any questions in the chat and we will answer them at the end of the presentation. We are going to begin by looking at the sketcher method of cooling design. The cavity block is displayed. I will make the cavity water assembly active. I like to use sub-assemblies to organize my designs. If we open up the water sub-assembly, you can see that there is no cooling part in here, which is related to sketcher water. But when I go into cooling or mold design cooling design and select one of the commands, a part will be made and then it'll take on the name of the sub-assembly it's under. So I have parallel plane selected. I'm going to offset this plane and say OK. Next, I am going to select cooling sketch and I'm going to add a couple lines for reference that represent the edge of the block. If the cooling was going to be the same on both sides, say the center line here, I could create a line of symmetry and then start creating my water circuits. I'm not going to do that. I'm not going to do a complete cooling design. It's more about the different techniques than the little details. So I'm just going to lay in some lines here, create a quick circuit. And have that cross line. Okay, I can move these guys around a bit. Something like that. Say OK. And now I can create cooling objects with the sketch. Need to type in my cooling line diameter. And then I have an option here of using visual analysis and giving it a value to check around it. So in this case, I don't want to be any closer than 3/4 of an inch to the part. I can see I still have room here and I don't want to violate anything. So again, I have room to drop that. I'm going to turn that off. I'm going to keep the sketch. I'm going to change the plane, update that, do the visual analysis again. And in this case, I can see that clearly violating the part right there. Again, we'll make a change to plane depth. Update, edit, and visual analysis. Now everything looks good. I can bump this up a bit. See how far away I am. And again, I could keep adjusting this until, I get it exactly where I want. Next option we have are the drill tips. And we can control the extension. In this area here, it's global, so all of them will change. And also control the type of representation for the end. If I want it flat, closer to what a gun drill leaves, I can. Ball end, if I was doing high or hardened material, or the standard drill tip. Say okay to that. So that's one method, just sketching on a plane, laying out my circuit. Another way I use is selecting the face I'm going to drill the water in, and then using a circle to represent the drill diameter plus my offset times 2. So 3/4 times 2 is 1.5 inches, and then 7/18. It's right around 2.218, so I just round it to 250. Now what I can do is I can go around and place these circles around the part in such a way that I'm close to the profile. Then I'm just going to throw one up over here like that for now. Now going to use cooling line. Give it a distance and pick the other centers here. So I'm just going to pick those 4 for right now. Probably bump it one more. Something like that. And then this line, again, just a little variation where I can place it and try and stay closer to the profile of the part. Okay, then I can add another sketch for my cross line. Again, I'll throw the circle in there, place it wherever you want, and then I can add a cooling line from the center, and instead of by delta, I can change that to reference and pick that line. Okay, I can now do my joining lines same way, by a reference, pick this face, and now I can pick the rest of the ends of my lines. Again, I can create the cooling objects. Again, with the visual analysis. So I can see that the angled one is violating. See how close it is. Yeah. So I would end up adjusting that water line. Just going back to the sketch. and then editing that, visual analysis. And I can see that now I'm not violating the part. Go to there. Good enough. Okay, so that's second way I can do my cooling. The last way that I will do is parallel plane. That way, say around 9. I'm going to select my cooling sketch. Do the dynamic section. And again, add some references for the block. And start sketching my cooling circuit. Bring these guys down. Push them over, or depending how you want them. And say OK. Cooling objects. Visual. Okay. Drag the section. And can definitely see we're violating the part. So again, we'll say OK. We can edit the sketch. Let's move that back. And go back to here. See, I'm a little too far over here. We're better in the middle. So again, the visual analysis finds a lot of the issues that come up immediately before you go any further. Okay, now we're going to move on to add cooling item with channel, or cooling item with channel. And we're going to use baffles to demonstrate it. Let's add a reference. And we can add a few baffles here. Okay, let's rotate them so the blades are in the right orientation. And now let's look at some of these options here. Right now it's on no interference, but if I change it to maximum length, you'll see that they all get longer except this last one. And the reason for that, I'm just going to say okay to this for a moment, is best explained by this picture here. So what happens when you use maximum length or maximal length and to closest, the only thing that is being done with the analysis is like extending a line from the very tip of the drill for the height. It's not looking at the side at all. It's merely looking at your tip offset from the very tip of your drill point. No interference is the safest way, as it takes into account the radial offset along with the tip offset to give you a better result and safer result. Okay, so let's edit this. And let us take a look at our offsets here. So we have tip offset, and we'll bump this guy up to 3/4. Again, maximum length, it says it's fine. Again, it's obviously not fine. But if I change it to no interference, now it gives me a much safer result. And if I were to say okay to that, you can see they've all been recalculated to the proper height. Again, editing it. Going to solid. No violation there. I'm going to add another baffle. And again, adding the reference line. And this one we're going to add somewhere around there. Again, we want to turn him 90. And right now it's on no interference. We would like to get a better result than what we're seeing here. We'd like to rotate it. So if I pick this, a rotation point, and I pick the center of that water line, you can see it moves the center here. If I don't do this, it's going to rotate it from the bottom. Now it understands to hold this point and rotate it about that point. And now I can, wrong way, let's go about the X. Yeah. So now as I'm rotating it, you can see that it's growing in length based on the rotation angle. So at some point, that's probably the best it can do, and I will accept that. We're going to add another baffle over here and show you kind of a difference. If the line is on a plane and rotated on that plane, picking that point that I showed you works. If I have a line that's not planar, that's kind of trailing up or down, I got to do a little more work to it. Okay, so I'm going to offset a plane. $16.5. Believe that's, yeah, that's good. And now I'm going to make a curve roughly where I want that baffle to be. And now I can go to add cooling item with channel. Picking the back of the block. Placing baffle there. And again, now I want to rotate it. So I can go to here. I can say 90. And now when I go to pick my point for rotation, I can actually pick the center of that curve I made. And now rotate it about that point till I get to the result I want. So it looks like I'm just a little off center. Well, we'll try one more. Oops. There we go. And that calculated as far as it can go, again, rotating about that point. So again, difference is I just have to make that curve to for the rotation. Okay. Let's go to the core side. Turn off this guy, turn on this guy. So you can see I have a cooling circuit laid out here. Going to throw a few more cooling items in here. Again, I'm going to go add cooling item with channel. This time I'm going to select a different component. One thing currently with you either got to use nipples or plugs to add the cooling, and then it becomes a pain if you don't have, or if you change a plug to a nipple or vice versa. I've made a water line part that I use. That's just the water line, and then I add my fittings to later. I'm going to change this to maximum, and when I add, change my radial offset there. When I add it with maximum length, just to highlight this sketch here about it looking only at the center point and nothing to do with the water line. When you use maximum or closest, wrong one. And I can place that right there. You can obviously see the water line is going through the maximum. Now you can see that it's clearly going through the, the ejector pin pocket. But again, it's because it's maximum or closest and not no interference. Okay. No interference is seeing I'm violating the parting line here. can change this offset. We'll leave it for now. And I can move this guy to another location. Make sure I'm 3/4 below. Change this to 0.3. Shift him over a bit. And now you can see that it goes all the way through. And what I'll typically do is I'll use no interference and know that I'm clear. And then I can change this to closest if I want to drill all the way through. Okay. Got a few more lines here. Yeah, he's going to be difficult, so there we go. Add a couple more. Move him over. And now I can look at this one and determine, well, maybe what I can do with this guy is move him over, invoke individual control. Oh, actually I didn't have to. Seems to, oh, that's why, because it's the closest. Let's go to no interference. So now you can see it stops there, but with individual control now, I can take that one and rotate it. Let's go back to group and move this guy over a bit. And now I can group control, pick this guy, change him back to closest, back to group, and say OK. Going to add a cross line, and then we're going to look at doing some joining lines. So in this case, I may use reference cooling channel, pick this one. That works. And then if I wanted to do up lines here, again, I can because they're not all the same height, I'll just need to do this multiple times. that for the reference. Okay. The other way that people will do joining lines is going with delta. And the reason they'll go that way is because they have control of this height that's not tied to another water line. So the one thing about doing the add reference is if I ever delete this water line, the up line becomes dead there. I'd have to edit the add, possibly change it to delta, or reestablish a relation to another water line there. I'll add the last one. And bump that up a little. Looks good. Okay. So that's a couple of the things with add cooling item with channel. Again, no interference is your safe one. Maximum length and to closest can give you some trouble, but again, understanding how they're analyzing or how they're determining the length gives you an understanding of at least why it gives you the results it does. And now we're going to go on to a couple analysis tools. So let's go take a look at cavity water here. So here I have two different layouts or strategies. One of them I had angled lines with minimal baffles. One of them I had planar water with a ton of baffles. And what this can really do, this cooling distance map we're going to look at, is allow you to see your cooling coverage before you cut it into the block, before you send it to cool and warp, and before you send it to the floor. So again, big time saver. Let's go to here, turn off the block. So the first step is pick your cooling channels. Typically I'll do this before I cut the water in. It's just find it easier to turn things on and off and select all the water. If your water, I think most people make it one color anyways. If you do cut it into the block, you can still use cooling distance map. Okay. I'm going to select my water components. Middle button. Now it wants me to pick the active faces. These are the part faces. So in this case, it understands, you know, those are from the cut active and that. Again, you can select it by color if you had an imported job from someone, maybe through step or that, as long as the colors and you can isolate the part color or parts faces, you can still run this without any issue. I'm going to say OK to that. Now we get into the cooling ranges, and again, whatever distances you want to see. You know, usually I put my good in the middle and then kind of go both ways. And then, you know, maybe anything and 1.8 and then start analysis. It's going to take a minute or two. A lot going on with what it's doing, but the results are very beneficial. Okay, results coming up. Okay, so we can see again by our color ranges, the results, and essentially anything light blue, green, and yellow is what we really want to see, and anything especially purple and red we have a concern with. So see over here, it's a lot more red in this area, some purple in here, and overall over here I think we have better coverage overall. Definitely would have to add a baffle on this circuit. But again, the efficiency and the minimum amount of baffles on this one seems to do a better job. I could probably manipulate or rotate the baffle there, maybe add another one in this area there, and I'd have a pretty good coverage. And I could do this again before I send this out for cooling and warp, rather than send it there, have them tell me, send it back, make my changes. You know, and again, this can be run in a meeting, or before the meeting, you can publish it to a PDF. It'll take a minute for it to come up. Right there, tell it, trust me always. It'll just take a second to, there we go. So you can have this report already done, and there will be in the bottom there's the legend. Okay, currently it's in metric, but again you have your report. Nice thing here too is you can put your cursor close to the face and click anywhere as you want, and it'll tell you how far away you are to the closest cooling area. So, and again, you can make a map of this for the customer to show them how far away you are, and maybe, you know, have him make the call if you can't get something in there. But again, you're going to be able to give them some numbers to what you have. Okay, I don't believe a lot of people use this, but again, I think it's a great tool for saving time, and saving time saves money. The other tool that I don't know if anyone uses or how many people use it is cooling or analyze cooling circuits. So here I have a block. It's got all these circuits in here. It's very busy. It's just a generic block that I made it into. And when I come here, I can go tell it where my stop faces are, and typically what I'm defining here are any diverters. Okay, so it doesn't understand the diverters. In this case, I'm using a different style of diverter. If you were putting diverters inside of the cooling channels, and I had a diverter that was in this one, I would just pick that, and then I'd go on to the next section that would have a diverter and pick that, so it would know that that's like a stop channel. I'm going to unselect those. I'm going to middle button to accept that, and now you can start picking what you know is an inlet. You may want to leave your engraving, your ins and outs here, but you can pick an in Say start analysis. Whoop, going through. I can already see that I have a problem because it's selecting 4 ins and outs. Probably because there's a missing diverter here. So let's go back here. I'm going to pick a different in and out for a second and say start analysis and do a hide other. And now I can see that that is a good circuit. If you select next, the coloring's going to stay, and then I'll have to change it after back to my coloring here. So I'm going to cancel this for a minute. Let's go back to here, because again I am missing a diverter here, and what I did was I used remove and extend so that I would cause that issue, and I can go back into cooling distance map, not cooling distance map, sorry, analyze cooling circuit, again define my stop faces. It remembers the other ones that I defined, and come back here, middle button, and now I can pick and I can see that that's a complete circuit. Back, new circuit, pick the next one. That black one, that's a complete circuit. Back, next circuit. So the advantage of this is that I can check and make sure all my circuits are good. There's no dead spot. There's no in without an out. There's no, maybe I clipped a line going through. I'm confirming all of these circuits before I send the data down to the floor for them to add the water into. Again, saving time, saving money. Just as a quick check again before it comes an issue after the fact, and you're reacting instead of planning ahead and avoiding any rework. Okay. And again, could do all of them. I'm not going to. I believe that's it. Well, that wraps up our webinar for today. You can visit our website at www.cimatron.com. If you're in North America, you can contact us at support-us@cimatron.com. And if you'd like to contact us by phone, you can reach us at 877-596-9700, extension 1.